Good evening once again, everyone. Melissa Raspberry. I have the honor and privilege of being the principal investigator for CS for All Teachers. I work for the American Institutes for Research, and we manage and support this virtual community for teachers of CS. So we're so glad to have you with us here tonight. We are recording this session so that others can access it later in our archive. And as I mentioned earlier in the chat window, often these small but mighty groups are some of our best webinars, so we're glad that you're here with us tonight. We have three wonderful presenters that will be sharing some terrific information that I think can be directly applicable to elementary classrooms and can be some terrific resources for you to take note of. But before we get started, I just wanted to mention that I am here and I can provide some technical support if you have any issues throughout the webinar. We did want to point out to you that we hope that you participate via audio, and I can give those instructions again about how to get connected. But we do ask that you mute yourself when you're not talking. There will be time to ask questions and to participate orally, but just to help with the background noise, we ask that you mute your lines. And you can find that on your top toolbar. You should see the dark gray or black colored toolbar at the top of your Adobe Connect screen, and you should either see a little microphone or a phone icon. And if you click the little arrow beside it, there's a drop-down menu that'll say mute my line or mute my phone, and then you do the very same thing to unmute yourself. So we just ask that you do that again. We want you to participate orally, but as folks are presenting, it helps to cut down on the background noise. We were all joking earlier. We had a dog licking himself, and my cat's running around my house. So we know that it's a time of the day where there could be those crazy things happening in the background that we don't want to disturb others with. So certainly that happens, but no worries. But with that, I'm going to go ahead and turn things over to Nancy, who will be leading our efforts tonight. So Nancy, it's all yours.
Thank you, Melissa. Well, we are beginning our webinar. So this is Computer Science, Computational Thinking in the Elementary Classroom. And we would like to introduce ourselves. My name is Nancy McGowan, and I am an instructional math coach for Hoover City Schools.
And I am Karen Derrick, a technology integration coach for Hoover City Schools.
And I'm Ashley Waring. I'm a district technology integration specialist for Trustful City Schools. I'm a CS for All Teachers community ambassador along with Nancy, and a Code.org computer science fundamentals facilitator.
Thank you. Computer science in the elementary setting varies greatly from state to state. It can look very different from school to school in the same district. As teachers of elementary students, we are given the task of laying foundations in computer science using computational thinking. When Ashley, Karen, and I began talking about this, we decided we wanted to have a webinar to discuss just these things. For example, what is meant by computer science in the elementary classroom? What does computer science look like, and what are the expectations as far as learning activities for students in K through 5? How do I know if I'm teaching computer science or a skill related to this? So our goal for tonight is to present computer science standards, highlight examples of activities that already take place in the classroom and are building blocks for computer science. We also hope to provide you with ideas and resources for unplugged activities to try in your classroom.
And so I would like to start off with a great quote by Jeanette Wing, and this is from an article in 2006 on computational thinking. Computational thinking is a fundamental skill for everyone, not just for computer scientists. To reading, writing, and arithmetic, we should add computational thinking to every child's analytical ability. And so utilizing unplugged activities is a great way to integrate computer science into your existing curriculum before or even instead of online activities. And so using games and hands-on activities help your students to make connections. After all, when students think of computer science, the first word that comes to mind is computer. So how can you possibly accomplish computer science without a computer? Well, it's easy. Computer science has its foundation in logic, and we use logical processes in all that we do. And soon students are able to discover relationships all across the curriculum.
So at this time, Melissa's going to, go ahead. I was just saying, Melissa's going to pull across a poll, And if everyone could please respond, here's the question. Do you use computer science and computational thinking standards in your classroom? Would your vote be standards? What standards? Or I am aware that standards exist but do not use them yet. Or I often use state standards to build my lessons. Or I often use ISTE standards to build my lessons. And then, of course, you can also just not vote. So we're going to let everybody have a chance to respond. And why don't we come back to the response here. Ashley, if you want to move ahead, we can. So far I see most people are aware of the standards, but they do not use them yet. And then we have a tie for using state standards and ISTE standards.
All right, so it seems like everybody's pretty familiar that standards exist, at least, and so I just wanted to kind of talk about the standards that we're going to be referencing. So the computational thinking standards that we use in the state of Alabama, which is where the three of us live and work, we recently passed standards for our entire state for the Alabama Digital Literacy and Computer Science course of study. And that course of study was developed, I was able to serve on that committee to develop those standards, and we used the ISTE standards and the K-12 computer science framework to work on and develop our own standards. So here you can see you have the ISTE standards, which we really liked their verbiage. Everything described on the ISTE standards is the end product for the student after they learn the standards. So like the student becomes an innovative designer, the student becomes a creative communicator. So we really like that verbiage. And then it's very creative and yeah. And then the K through 12 computer science is a combination of core concepts and core practices with computer literacy, educational technology, digital citizenship, information technology, and computer science as the emphasis. So, like I said, we adapted the language of the ISTE standards for our own standards in the state of Alabama. So here you can see the strands for each of those standards, and one of those is computational thinker. And in our course of study, we define computational thinker as a problem-solving process that includes but is not limited to formulating problems in a way that enables us to use a computer and other tools to help solve them, logically organizing and analyzing data, representing data through abstractions such as models and simulations, automating solutions through algorithmic thinking, identifying, analyzing, and implementing possible solutions with the goal of achieving the most efficient and effective combination of steps and resources, and then generalizing and transferring the problem-solving process to a wide variety of problems. And the goals for our standards in the state of Alabama are for students as computational thinkers to explain how computing is an integral part of the world, and for students to use problem-solving processes to understand how to create and debug an algorithm, and to evaluate and create new informational representations which successfully reframe the issue. I'm going to scoot ahead. And y'all, don't forget that if you have questions, feel free to drop them in the chat box for us. This is a chart that was adapted from a Google course. Google has an entire course on computational thinking for teachers or administrators, which I'll drop the link in the chat box in just a minute if you want to check that out for yourself. But the examples that they use are geared more towards secondary, so Nancy helped me adapt this for our elementary grade levels. So you can see the computational thinking concept is, developing instructions to solve a problem or steps for a task, which would be how-to writing activities or a recipe. And then for generalizing patterns and trends, things like logic problems in math, guess my rule. Scientific studies or research like population and plant growth could also be used there. So just some ideas of how those computational thinking concepts apply in subject areas. All right, and then I wanted to share with y'all these excellent infographics, which were found by somebody else who was on the Digital Literacy and Computer Science Course of Study Committee with me, Amy Bates, who is in Coleman, Alabama. She found these from Robert Resources. And again, I'll drop that link in the chat box in a few minutes. But just some great examples of how computational thinking can apply across the curriculum. So you can see using even something like abstraction, which is focusing on what's important. Like if you're making a peanut butter and jelly sandwich, for example, it doesn't matter what kind of jelly you're using, what kind of peanut butter, whether it's crunchy or creamy, or you're using wheat bread or white bread. That doesn't matter if you're thinking in terms of abstraction. It just matters that you are making a peanut butter jelly sandwich. You have peanut butter, you have jelly, you have a sandwich or bread. Another example of abstraction is taking something that would be a really detailed sequence and taking out the extra details for that, only adding that necessary knowledge. All right, and then I'm going to scoot ahead to my other example, which is pattern recognition. Pattern recognition to me screams math. We teach our kids pattern recognition from, kindergarten up. So I think that's a place that we really see pattern recognition, and it also applies to computational thinking. So you can look for those similarities or trends. Times tables is an awesome example. Sorting and classifying activities or sorting and classifying numbers would be great ways to include computational thinking through math and pattern recognition. And then I have two more posters. The next one is algorithmic design, which is basically a step-by-step instructions. So things like, sequencing in reading, or even, steps in a math problem. Again, you could have how-to or recipes here. Steps in an experiment are also great ideas to apply that computational thinking across the curriculum. And it kind of shows you where or how important computational thinking is, and not just in a computer science bubble. We really want to push computational thinking across the curriculum for our students to help them be successful in all areas. This is another one that just screams math for me, is decomposition. And I immediately, as a background of a 4th and 5th grade teacher, immediately, and Nancy probably can back me up on this, but I think fractions right away, breaking them apart. Yeah, those are some great examples for decomposition from the same resource. Okay, and then this is something, a chart or infographic, I guess, too, from Michigan State University's College of Education. They have an MAET blog, and this is from February of last year. But this kind of reiterates what I've been saying about computational thinking and how it can and should apply to every subject. So you can see computational thinking is breaking down those complex problems into manageable chunks, whether it's, we do that all the time in math. You do like mental math to help solve larger problems and that kind of thing, so you're really breaking it down into manageable chunks. And I really like the iteration here of identifying and using a sequence of steps to solve problems, also computational thinking, making sense of data, breaking a complex problem into smaller ones that are easier to understand, which is just another way of saying that you're breaking them into manageable chunks, and then reducing the complexity to focus on the essential details of a problem, and that's another way of thinking of abstraction. So just some great references for understanding computational thinking and how it can apply across the curriculum.
Thank you, Ashley. That is wonderful, and I love the connections to math and all the different subjects. So this is a model for design thinking, and design thinking is a method of working through a problem. Steve Jobs is quoted as, "Design thinking is not about how an object looks, but how it works. Our elementary classrooms are grounded in guiding our students to be productive thinkers and problem solvers. So with this in mind, we go back to computational thinking, which actually so nicely showed us all the different infographics. The model for computational thinking is very similar to the design thinking model. Students decompose a problem, they find patterns, they represent their data, they use or create an algorithm to derive a solution, and then computational thinking involves a student's ability or the development of an understanding that a problem is more than a procedure. It is a method of thinking, and this method can be generalized to fit other situations, not only in computer science and math, and this method will help a child to be accurate, efficient, and effective in their work. Oh, and take a look. Ashley has put in standards, framework, course of studies. You have so many resources in the chat window there. We hope that you will take advantage of those. And as we move forward, I'm going to have Ashley to post a link for my first activity, which is parity. And parity is the use of even and odd numbers. In computer science, information is communicated in bits. A parity bit is also known as a check bit, and it's a single bit that is added to the original binary string. Well, the parity bit is set to either 1 or 0 to make the total number of 1 bits even or odd. To communicate and practice the use of even and odds, students can use the Unplugged activity that you're going to see in the chat window there. There's the link. Thank you, Ashley. And it's called Sink or Swim. So it's a real fun game. And to differentiate, you can change the type of dies the students use as well as the number of dies used by the players. This game I've just got through playing with first graders and second graders this past week, and then we also ramped it up and used it with fifth graders. So it's very, very flexible. You can use it in a variety of settings. Okay, so our next Unplugged activity is a computational thinking game called NIM, and Ashley is going to load up a video that you can take a look at later, because I think that videos are, for me, so wonderful because it explains in great detail sometimes what lots and lots of words cannot. So here we go. The goal of NIM is to play so that your opponent takes the last counter. The students have to develop a strategy, and I'm going to move forward to a little recording page here. The students develop a strategy to win the game. With each turn, the players can take 1, 2, or 3 counters. Okay, so here are the variables. The number of counters to begin the game, the number of counters taken during each play, and who plays first. So the question to pose to your kids, do any of these variables have an impact on the outcome? Well, here are some ways to pose this to your kids. For the first time, when the kids play, the teacher should read the purpose and the directions without giving the students a recording page. Then ask questions. So what do you have? What kind of questions do you have about this game? So they're starting to deconstruct the problem. The students play the game a second time, and then you can introduce this data page that you see on the screen. After the second play, what information in the table is helpful to know, so the kids are identifying data, and they identify a problem. How did you determine the number of counters that you removed during each turn? So is this a number random every time, or can you construct an algorithm? So the kids are already thinking on this because they really want to win. So they're going to be generating a solution. And this particular handout will help them kind of see patterns. It's another way, sometimes we call it a what I see table, where the kids construct their own ideas and thoughts. And so what thoughts do you have in developing your own strategy so that your opponent has to take the last counter? Are there a minimum or maximum number of counters needed to play the game? And if so, how did you determine this number? Have students to play a third time and continue to record the data and then test their solutions. So when they use the spreadsheet, they're going to record, they will sort, they will organize data related to the game, and this process not only helps them look for patterns, but it also provides a purposeful setting in which they can utilize mathematical skills of counting backward and find the difference in 2 numbers. And then, of course, differentiation for the game, prescribe a specific amount of counters for the players. Can the game be played by taking away different numbers of counters? What if you change the strategy so that the winner collects the last counter? Can you design this game so that it can accommodate 3 players? All of these are ways to differentiate the game of NIM and to use it for computational thinking. On our next slide here, I wanted to talk about so many times we say, I don't really know if I'm integrating CS standards. I don't know what computational thinking looks like. So the purpose of our webinar was to make connections between the foundational skills of computer science and the learning activities that is already taking place in your classroom. And we all know there are so many routes to accomplish computational thinking, and having access to a digital device should not be a roadblock. So the information in the chart is by no means comprehensive. However, as you look at the chart, you may see ideas or variations that you are using in your classroom. And I'm going to skip on to the 3rd through 5th. So when you look at these, do you see any activities that you are already using in your classroom, or do you see a variation? And also, I would like, if you don't mind, if you would be so gracious as to share, could you put in the chat window, we're going to give you guys a couple of minutes to put in the chat window any items that you can think of or connections to other curriculum areas or suggestions or links to resources that other teachers would be able to use when they view this webinar. So take just a few minutes and look and see. We'll take just a few more minutes and then we will move on. Thank you, Kristen. Oh, thanks for that link. I appreciate that. But as you can see, when you look, listing the and for kindergarten, listing the sequence of events, Karen's going to be talking about some conditionals coming up. 1st grade, classifying and sorting information. If you are familiar with counting collections, or even if you're not, this is a wonderful foundational activity for computer science. 2nd grade, creating an algorithm for other students to follow. This can be a set of directions. And then 3rd grade, numbers or letters using to represent information in another form, testing and debugging items, and now we'll just let you read the rest. Oh, Scratch. We love Scratch here in Alabama, Kristen. Thank you. I see Shauna. We're going to give Shauna a chance to type in her item right there, and then I will, yay. And then I'm going to turn it over to Karen. Oh, thank you, Shauna. Yes, code.org. That's wonderful. Okay, Karen, I'm going to go ahead and move it forward to your slide.
Great. Thank you. Thank you, Nancy. So as a technology coach, my focus this month with my kindergarten through 5th grade teams is on unplugged computational thinking activities. And so the activities that I'm sharing with you today are the same activities that the teachers are participating in during my monthly PD. And so after we complete these activities, we go back and we take a look at the computational thinking strand of the Alabama LCS, and the teachers discovered that we have covered most of the standards with these unplugged activities. And so the first activity I have for you was first introduced to me over the summer when I attended a Pathfinder Summer Institute on everyday computing, and that was integrating computational thinking in elementary math. And so this is called sorting networks. And in this activity, and it's actually originally from csunplugged.org, you start with 6 students who stand in the boxes that are on the left, and that is input. And so you give each student a card, and it's a number. And so the students are lined up on the squares, and then the teacher explains that we're learning about how computers sort numbers. So here they are standing in input. And so then they follow the arrow to the circle. And so now they have a partner. And so with their partner, they compare their numbers. And so the lower number follows the arrow to the left, and the higher number follows the arrow to the right. And so what the students are doing, going from circle to circle, is the processing. So we've started with input. Now the computer is processing. And so then they end up at output on the squares, and they are now lined up from least to greatest. And so with this activity, it's very easy. You can either take chalk and draw the pattern out on a hard surface, or I purchased a tarp from a local hardware store and found 2 cans of spray paint, and now I have a tarp that I carry with me everywhere. And so with this activity, remember it's the students take a look at how computers sort numbers, gaining an understanding of input, processing, and output. But then at the same time, students are sorting numbers, especially in the younger grades, kindergarten, 1 through 10, 1 through 20, moving on up to first grade, 1 to 100. But then you can also still use this map with the older kids with sorting fractions. And some of my teachers the other day even came up with multiplication problems. We could use addition and subtraction in second grade. And so my teachers are very excited about borrowing my map, my tarp in the near future. And so then I'm going to move on to the next activity. And that next activity is writing algorithms. And so in this activity, students will work in small groups to write the steps to solving a math problem. Now, we all know that there's more than one way to solve a problem. So each group has a different strategy. And so as they are writing the steps, then they're writing the algorithm. And so then they will swap strategies with another group, and that second group then is following those steps. And if they're not precise and they can't seem to solve the problem, then they have to go back and debug. And when they're debugging, they're having to make those steps more precise. Now, this can also be related to number talks where students share their strategies for solving a problem as well. And so we can relate this in computer science to decomposition. And on the mathematical side, students are making sense, they're modeling, and they're making use of structure. And then computer side, we have debugging. And so on the math side, the kids are looking back, checking for reasonableness, precision, and efficiency. And really, students encounter algorithms in math class through order of operations, word problems, basic logic of what comes first in solving a problem, and looking at the most efficient way to solve math problems. And so really, before long, students will begin to see algorithms all around them. And so now I'm going to take you to this next activity, and it is conditionals. And so in this activity, students actually gain an understanding of conditionals. And this comes from a left brain craft brain called If Then Backyard Coding. And here one student acts as the programmer while the rest of the class acts as the computer. And so after 2 or 3 commands, then you're going to switch up the programmer and have the students go around and trying out being the programmer. So for example, a student could say, if the number 50 is even, then you stand on 1 foot. If the number 49 is prime, then you tap your head. If the number 13 is odd, then you hop, else stand on 1 foot. Now what's interesting is the other day I was passing by a kindergarten classroom and I heard the teacher ask her students if 7 is greater than 4. So I immediately came up with, wow, they could use a conditionals game right now. And so I later talked to the teacher, and she really liked that idea because she thought, you know what, all the students will be standing up, and then she would get a quick assessment for understanding in the classroom. And so next, sorry, my mouse just popped off my screen. There we go. And so we can also relate this conditionals activity to the commutative property of multiplication or even to addition. And so if I switch the factors 2 and 3, then the product will still be 6. Or if 2 times 3 equals 6, then if 2 times 3 equals 6, then 3 times 2 also equals 6. And so before long, you can see where you can use this activity easily from kindergarten all the way through 5th grade. And so again, in computer science, they're learning all about conditionals. And then on the mathematical practice side, students are making sense, they're reasoning, they're making use of structure. And I was talking to a math coach today, and she was very excited about integrating this into geometry units as well. And using, if the quadrilateral has 4 sides, then do this. And then finally, my last activity is my robot friend. And this activity comes from code.org. And with this activity, on the computer science side, students are using sequencing. They're learning about algorithms, loops, and debugging. And so with this activity, students are programming a robot. And that robot is an arm, a person's arm, to stack cups in a specific design. And this is a great activity that lays the groundwork for programming while connecting it to several math standards. In fact, when I met with teachers last week, they were all excited after playing My Robot Friend because they were able to relate this to fractions, angles, patterns, even, odd. They were looking at diameter and radius. The younger grade teachers were looking at one-to-one correspondence, number lines, measurement, and data. And the older teachers, area and volume, how they could relate it to that as well. And so you can find these and many more Unplugged activities from our resource page here. Code.org, Hour of Math Plus Code, CS for All Kids, CS Unplugged. And so feel free to see all those great activities.
And if I just want to go back just for a second, since we have time, the CS for All, which obviously I'm a little bit biased for code.org, to be honest, but the Unplugged activities are great. They're free, which is what we all love. The CS Unplugged is a link that was introduced to me by somebody who we're in Alabama, we're very familiar with, Dr. Jeff Gray. He's a computer science professor at the University of Alabama. We kind of call him the grandfather of computer science in Alabama because he kind of started the whole movement for us. And now we have a statewide course of study and all of that, and really we kind of thank him for getting that ball rolling. But CS Unplugged is an awesome website. You can apply filters to a search. So if you're looking for a particular, which I'll get the live link and drop it in the chat box in a second for CS Unplugged, but you can filter it by like what subject you're teaching, what standards you're teaching in that subject, and then it can help you find unplugged computer science lessons to kind of double dip, I guess, with one lesson, or two birds, one stone. And then Ignite My Future, the curriculum connectors, is similar, but it's divided off into curriculums. So you would have like social studies and computer science connections, or English language arts and computer science connections, things like that in that site. So I'll find those live links and stick them into so that you can access those. So I just kind of wanted to touch on those two before moving on. So this is the article that Karen mentioned or referenced earlier with the quote from Jeanette Wing. This is a great article that dates back to 2006. So she's obviously been a proponent for computational thinking in the classroom for many years now. I can't believe that was like 12 years ago, but doesn't seem like that was that long. But we referenced this a few times in the webinar, so we wanted to be able to provide the article for you here. And it also further explains computational thinking and really breaks it apart and what that really looks like. So again, just a great article. All right, and then we wanted to make sure we gave some time for questions and answers. So if you have any questions, feel free to drop those in the chat box. I'm going to go find those links to give you all some time to drop those in.
Thanks so much, ladies. This is, oh, I'm sorry.
No, that's fine. Go ahead, Melissa. I was just going to say, make sure you go ahead and pop that in while we're wrapping things up here. And Ashley is posting her link. We would love to see any questions or comments in the chat window. And we appreciate you sharing all of the great resources that you guys use. Go ahead, Melissa.
Absolutely. Yeah. And I know that we have a couple of program providers on here, and I'm a former third grade teacher myself, and so this is just so exciting because you know, I'm seeing so many of the parallels that could happen. And one of the things that I've often said is that, you know, it just makes so much sense. Like when I started to learn more about computational thinking, I kept saying, oh my gosh, like I was already doing these things in my third grade classroom. I just didn't know that's what it was called. So a question that I have, and this is like a kind of like a more general thing, not specific to these resources, but I think it's an important thing to consider is, so when you're starting out in wanting to get elementary teachers engaged in this and kind of help introduce it to them, like where do you feel like is like, what's the best way to get them started so they're not feeling uncomfortable, nervous, scared, that sort of thing? Like, how do you first get them going and kind of show them the way so they're not feeling too overwhelmed?
Well, for me, as a math coach, I like to link a lot of activities to math. And in fact, I had a conversation just the other day with a teacher. This was not math, but she was just talking about a writing activity. And I said, oh, my goodness. I said, I was just reading about this. And I said, we have a webinar coming up on computational thinking. And she goes, oh, well, good. So just pointing, I think it's very important to point out what you're already doing in your classroom. I think that's a huge confidence builder because so many times we have items added to our plate and we go, oh my goodness, computer science, I'm not really a fan of that, or maybe that's not my strength. And so it seems like it's going to be overwhelming, and it's really going to be so easy because so many items you can just check off and go, oh, I am doing that. As Karen mentioned, when you have writing activities, when you're ordering, and I just think back to some of our classrooms, first, second, and third grade, they have stories which they need to put in sequential order, or we ask questions about stories that we read in the classroom. Sequential order, computational thinking, it all goes together.
Yes, that's true. And in fact, each month when I meet with my teachers, they really are relieved to see, because I've been focusing on one strand a month, and they are so relieved to see that they really are already doing this in the classroom. And it's just me introducing, having them try some of these activities, and then we go back and we take a look at those standards, and they really are excited and relieved, and I even get some cheers at times as well.
Thanks so much.
And sorry, I was busy in the chat box. But Nancy, I think there's a question for you as a math coach.
Right, I see that. Nicole, give me a little more details when you say sentence frames for students to respond. If you can kind of elaborate on that, that would be very helpful. Oh. Ah, okay. All right. My algorithm starts with then, okay, I will see if I can pull together a list, and then if you can just give me your contact information, maybe give your contact information to Melissa, or I will post it on the elementary CS for All teachers. That's really wonderful. I appreciate you asking about that resource. Absolutely. Okay, so I will look for some guiding questions and pull some of those resources together. Thank you. Thanks, Kristen. We appreciate you being here. Do we have any other questions? Thank you, Cindy. I appreciate that.
We are happy to stick around if there are any other questions that we could answer for you, but we did want to mention that there are a number of upcoming activities that we hope that you will check out on November the 27th, so the week after Thanksgiving. Throw me off that Thanksgiving is so early this year, but we're going to have a webinar about learning from home, online professional learning for teachers of CS, and there's going to be a couple of programs, the College of St. Scholastica and We Teach CS is going to be sharing about professional learning opportunities for teachers that you can do at home, online. And then, of course, CS Education Week is coming up December 3rd through the 9th. The link there gives you, sends you to the central point for the CS Education Week and can certainly help you find lots of different things and ways you can get involved. We are going to do our annual photo challenge, so look for more information from us about that, where we hope you will share photos of how you're celebrating the week. And then we also hope that you'll bookmark the events page on the site, which I'm going to share that with you momentarily in the chat window. This is where we list all of our activities, as well as we share lots of things on Twitter. But you will soon see on the Events Archive page, the Events Archive tab on the events page that we will post the recording and also share the PowerPoint that we had tonight, because there were so many great resources here. But again, we thank you for connecting with us, and we're happy to stick around if there's any other questions that you have. But certainly have appreciated you being part of this with us and sharing in the chat window so much. It's been terrific to see all these wonderful resources in one place. So have a great night, everyone.
Thank you, Melissa, and thank you to everybody who participated.
Thank you. Thank you.